Hello. I wanted to go over one giant problem that's very similar to what we've been working on today, just to kind of give you guys a little bit of extra help or notes and kind of see what kind of questions you guys are coming up with. So we're going to be looking at this Ferris wheel. It's got a midline of 40 feet, a radius of 35, and it makes one full rotation after 30 seconds. So one of the things that we're going to look at here is just filling out our circle to get us started and ready to work on this. So our midline is the line that goes right through the middle of it. I think that's about right. Pretty close. Okay, so there's my midline, and that midline has a height of 40 feet. Then I have a radius that is 35 feet. So from the middle out, we have 35 feet. And we're going to complete one rotation of this circle here. That rotation, and we're always going to go counterclockwise. That rotation takes 30 seconds. So, if we wanted to figure out how high we are on this circle, we need a few pieces of information. Okay, so one of them is we need to know our angle. Right? If we know our angle and we know our radius, we can figure out how high up we are. We would just have to use our sine equation. So essentially what we're looking at is we're trying to find the sine of some angle is equal to its height. Oops, I did that in the wrong color. Its height, which we are saying is that orange, over the hypotenuse, which is going to be our radius. So we're looking at an equation that looks like this. The key things here, though, are in order to get x by itself, we have to multiply sine by r. So we get r times sine of whatever theta is equal to x. And that's going to give us how tall something is. But if we want to find our overall height, now we have to do r times sine of x, sine of theta, plus our midline is going to give us the actual height. So this here gives us the orange part, which is just how high above the midline we are. Then we add our midline, and that gives us the total height. So the one thing we need to look for now is this unknown. And that is, what is our angle going to be? So if we look at the angle, that's going to change depending on where this radius is. Remember, our point on the circle could be here, could be down here, could be right up here. The radius isn't going to change. Nothing's changing about this equation except for the actual angle or the reference angle that we're looking at. So when we're looking at the reference angle, we need to make sure that we are calculating that. And that's where that rotation comes in. So it says that this whole thing is going to go 360 degrees every 30 seconds. So if we know that it's going to go 360 degrees every 30 seconds, we can figure out what's called our angular speed. Okay, our angular speed is essentially just saying how many degrees do we go for every second. So in this case, we go 360 degrees every 30 seconds, which gives us 12 degrees every second. So if we know how long we've been on the Ferris wheel, we can now plug that in for our angle. So what we get is this general equation here, which is going to be our radius times the sine of your angular speed. So in our case, we're going to call this our angular speed. We were doing 12 degrees per second plus our midline, which was 40. And I'll put the radius in there because our radius was 35. So we get 35 as our radius, 40 was our midline, and 12t was my angular speed. That's going to give us the overall height above the ground. This angular speed here is very important because this will allow us to find any angle that we need to just based on how much time has gone by. And so we're going to use this equation, this general equation today. Now again, I've highlighted a few things. This is our radius. That's our angular speed. And that's our midline. So I'll give you a second to kind of look at all of this here. Okay, so now we're going to go down and we're going to find some specific points at time t. So again, our equation that we're going to be using, I'll rewrite that right here, is going to be the radius of, I'll just do a copy paste. Here's our equation. So if we look at this, we are at time of 5 seconds on this first problem. So that means we have been rotating for 5 seconds of this 30. So if we look at this, we can say that this is at time 0. Halfway through, the rotation is at 15. So this is going to be 7.5 up here. So we're approximately somewhere right around here. And that's just a guess. That's going to be right around 5 seconds. Okay. So let's see how high above the ground we are at that particular point in time. So our radius hasn't changed. Oh, and these little numbers I'm putting here, those are just times, okay? Those are just to kind of show exactly where we might be at those times. So at 5 seconds, we have 35 times the sine of 12 times 5, because t was 5, plus 40. So we get 35 times the sine of 60 degrees plus 40. On our calculator, the sine of 60 is 0.866. So we get 35 times 0.866 plus 40. And if we multiply all that out, and then add the 40 to it, we're going to be at 70.31 feet above the air, above the ground. And that makes sense because we're up above here at this point. So at that point, we're about 70.31 feet above the ground. So let's look at 10 seconds. So 10 seconds is going to be about right here. We're past that high point, and we're going to be looking at how high above the ground we are. So this is roughly at 10 seconds. We're going to be at that area there. So if we do 35 times our sine, our angular speed is again 12 degrees for every second, and we've gone 10 seconds, plus 40. So I get 35 sine of 120 plus 40. And if we look at this one here, we're going to get 35 times 0.866 plus 40. And that gives me the same 70.31 feet. Now you might be asking, why did I get the same answer? Well, the nice thing about sine is that we're just looking at that, how high above we are. And if you were to look at it, this here, this point in orange, is the same point here. We've just crossed the highest point. So you can see that every time we have a point, we have a matching point for sine that matches up with what we've been doing here. So there's always going to be those two spots. We're going up, 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 up. Then we start going down, 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 down. We're still getting lower, 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 lower. And then we go back up, 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 up. And we're going to hit our points twice every time. So it's okay you get the same answer. It's just the way that the circle works. So in this one, if we have t of 20, t of 20 now is going to be about right here. So now we're below the midline. So our answer should be something that is less than 40. And if we plug that in, so this is where t is 20, we're going to use our same equation. So we get 35 times sine of 12 times 20 plus 40. So 35 times the sine of 240 degrees plus 40. So that's going to be negative 0.866 now. And it makes sense because we're below the midline, so there's going to be some negative that comes in there. So we go 35 times negative 0.866. We get negative 30.31. Plus 40, and that's going to get us 9.69 feet. So now we're on this lower part, and we're only 9.69 feet above the ground. So you can see as this circle goes around, we're going to start to see that. So what happens when we get a number that's not like a 20 or 5 or 10? Well, it's the same thing. In fact, at 27, we're really close at making our first full rotation. So we'll plug that into our calculator. We're at 35 as our radius times the sine of 12 times 27 plus our midline of 40. so we get 12 times 27 gives us 324, and the sine of 324 degrees is negative 0.587. Plus our 40. So if we do the multiplication, 35 times negative 0.587, we get negative 20.545. Plus 40. We're at 19.455 feet. Which is good because we're coming up, we're approaching back to our midline, which is 40. So we started to go down, like I was saying. We were going down on this side of the graph. This is where we're going down. We're losing altitude. And now we're going, when you hit that bottom, we're going back up. So now we're going to be gaining altitude. So there's this rotation that's going on with sine, where we're at the up or the down slope. And it's okay. It's going to repeat itself because it's circular. All right. So what happens when we go past 30 seconds? Well, if you think about it, if 30 seconds is one rotation, then 40 seconds is just going to be here. And that's really just looking at 10 seconds. Because we've done one full rotation at 30, and then we have 10 seconds left over. And if we look, we had already done 10 seconds. Oops, 10 seconds is going to be, sorry about that. It's going to be about right here. So that's 10 seconds past our first rotation of 30, which is the same thing as right up here. So we're going to have 35 sine and since we've already done that problem, we know that that's going to be 70.31 feet. Because, as we said, a circle is just going to start repeating itself over and over and over again. So when we have a time of like 52, that's really just looking at about 22 seconds. Because after 30 seconds, we start over. Here's my 0 and 30 second mark. Boom, 22 seconds after that, we're going to be really close to the bottom. Really, 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 really close. So I just need to do my 35 sine 12 is my angular speed, and I'm going to be at 22 seconds plus 40. Okay, so if I do that, I get sine of 12 times 22 is 264 is my angle. Plus 40. And the sine of 264 is negative 0.994. We're going to times that by my 35 and then add 40 to that. And we're going to be at about 5.21 feet. Which makes sense because we are really close to the bottom. And the most bottom that we can get to is 5 feet, which is just our midline minus the radius. So we're really close to the bottom, and that makes sense because we're 22 seconds past, and the bottom would be that like 22.5. So let's start to take a look at the actual graph of this. So I've got a lot of stuff going on here. So I have a table of values. We know the equation now. So our equation is the height is equal to 35, which is my radius, times the sine of my angular speed, which is 12t, plus 40. And if I look at that on a graph, or if I put it into a Desmos table, we can go ahead and set that equal. Oops, let me get out of here. And put that into my calculator. So I have 35 times sine of 12, and we'll just say x plus 40. And I put that into a table calculator on Desmos. At 0 seconds, I'm at 40. Then, at 2 seconds, I'm at about 54.236. Then at 66.01, 73.287, 74, 808. So now we're going to start coming down because we've passed that first quarter, which would be 7.5 seconds. And now we come back to 70.311, 60.572. And so we're going to start to see that this table, as I fill it out, is going to start making that full rotation. And at 30, we're going to be right back where we started, which is just 40 feet, because that is our full one rotation. So as our table starts to fill out, we're going to start to see that circle where it's growing, growing, growing. And you can see that it's growing from here. Oops, wrong tool. Our graph's going to be growing here. It's going to start to go slower to here. And then it's going to be growing again back up to our 40. And that's just like we saw with our circle. We have our midline, and we see growth. Then we see decreases. And then as we hit that bottom, we start to come back up. So what does that look like in a graph? Well, we started at our midline, which is 40. We made one full rotation after 30 seconds. We hit our peak at about 7.5, and our peak is going to be 75. We hit 40 again at 15 seconds because we're halfway through. And then at 22.5, we're at the very bottom, which is 5 feet. And so we start to see this curve. And that curve is always going to repeat itself because it's circular. So we have this, what we call a sine wave here. And you may have seen this again in physics before. So a couple of the key features is we have our midline. Okay? Our midline is always going to be at that 40. And then, depending on where we're at, we also have our radius. And the most our radius can be is 35. So this has a change of 35 at its peak, at its valley, and it just keeps on repeating itself. And so then we have a maximum value of 75 and a minimum value of 5. And so we can see that this sine wave, looking at our key features, such as the midline and that radius, is just rotating around the circle, giving us different heights. And we can connect that to our equation up here, which says midline of 40, a radius of 35, and then that sine degree is going to tell us where that is on the graph. But it has a maximum of 75 and a minimum of 5. So again, this is all called our sine wave here. And through our table of values and our graphs, we can start to see exactly where we're going to be and why that circle has parts of growth, parts of decrease, and then it repeats itself over and over and over again. And just one key piece of information is that when we're dealing with a sine graph, we're always going to start here. This is always our start when we're dealing with sine. And we'll start to see a cosine graph here too. And we always go counterclockwise unless stated otherwise. And so today, for your work today, I'm going to give you a similar problem, and I want you guys to fill out a table and to sketch a graph and come up with an equation for this. And so it's going to look just like what we did here on this last part. We have our table of values, we have our circular graph, and we have our equation. And you're just going to be sketching it. It doesn't have to be anything perfect, but it's just showing all the possible values that we can get and where those are coming from, and then relating the graph to its key features in the actual equation. And if you want, you can even see on the graph, here's where we're growing. Now we're starting to decrease, 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 decrease. Now we're growing again. There's one full rotation, and now the circle restarts. Growing, decreasing, and then it starts to grow again. And so those are the key things we're looking for in our sine graph. Again, I'm going to give you a problem. It's going to be based on a circle with a height, a radius, and a certain angular speed. And all I want you to do today is fill out a table, come up with your equation, and then start practicing sketching a graph and showing all those key features of it. All right, if you have questions, please email me or get in touch and we'll take a look at this. I plan on giving us a quiz next week that'll be based on just equations and then our basic trigonometry stuff. The graph and the table, that'll come later, but really next week's quiz is going to be focusing on just our equations and being able to solve for sine, cosine, and things like that. Okay.